Hi, today we're going to talk about whether the derivative of a polynomial function, such as x to the n, is equal to n times x to the n minus 1, where n is a constant. N should be a constant because it's a polynomial function. It means constant exponents. So, first of all, we're going to talk about the definition of a derivative. So what do you mean when I say f prime of x? Well, by definition, f prime of x is the limit of there you go, f of x plus h minus f of x over h as h approaches 0. So where are you going to use this? Here, f of x, of course, is the polynomial function, x to the n. So therefore, f of x plus h is x plus h to the n power. So we're going to plug these here. So that's the limit as h approaches 0. So that's x plus h to the n minus, that's x to the n, and that's over h. Okay, so what we're gonna do next is we're going to expand this x plus h to the nth power. We're going to use binomial theorem, and for a short time I'm going to write it out. So that's the limit as h approaches 0 of x to the n plus it's n x to the n minus 1 times h, and then it goes on, and then I'm going to write the last two digits, that's n times x times h to the n minus 1 plus h to the n. Note that all the terms here have x's and h's in it with a constant. So we're going to subtract that by x to the n. Remember, don't forget that. And that's all over h. So now we're going to do something. X to the n here can be cancelled, which is great. So that's the limit as h approaches 0 of n times x to the n minus 1 h blah blah blah. Just gonna rewrite them all. That's over h. Now notice this. Okay, the only term that has no h in it is the first term. Now that it's gone, all of the terms here have h's. We can factor out that h by just h because that's the least number here. So that's the limit as h approaches 0. So let's factor out the h. H is outside, so what's left here? That's n times x to the n minus 1, and then something, the rest here is factored out. Here's n times x times h to the n minus 2 because one of them is taken away, plus h times n minus 1 because one is taken away as well. And this will be all over h. Hey, we can cancel the h's. So, cancel the h's. What we're left is the limit as h approaches 0 of the function n times x to the n minus 1 plus this things times n times x to the, there you go, plus h to the n minus 1. So now, hey, that's gonna be easy. Well, plug all the h's with zeros. Since this is the only term that's gonna be, there's not gonna be 0, So because this is a 0, 0 to any power is 0, this will multiply to be 0. All here have h's, so they're gonna be 0. So what's left is n times x to the n minus 1. Hey, so therefore f prime of x is n times x to the n minus 1. So we're gonna read, there you go.